All right, there we go. Man, I gotta fix my setup. I've broken my setup. I've done untold amounts of damage. Steel man, our frequencies are locked. Our frequencies are locked. We're forever interlocked. In regards to our frequencies will never, never become out of sync, not ever, because we're tuned in at 2.89. I can hear you right now, Steel Man. How you doing, Evil Eye? Good to see you. Welcome in, everybody. Hope everyone is doing well. I don't think I need to do much of an intro here. I'm just going to get some code done because I want to work on the video game a bit. Man, that looks ugly up there. I'm gonna have to fix all that. I'm gonna have to spend some time after the stream and clean all this up, make it nice. I'll do that. So I thought what I would do is I'd focus on a couple of things with the video game work, with the multi-user dungeon and all that good stuff. Um, Here, let me do this, and I'll switch over. Yeah, here we go. So one of the things that I had going on, I just kind of want to do this on stream and have it on record in case I want to create like a little bit of a tutorial after this. But one of the things I have going on here is a multi-user dungeon game. These games are fully text-based. It used to be how you would connect to video games back when video games were first kind of coming out in the modem days. And this is how it would work. And so well, let me zoom out a bit. Let me do this. This should be a little better. So you see all the text here. It explains what you're seeing, right? And where you're going. So this is all fine and dandy. Everything's great. I've turned this off, so nothing's working. Usually I have the game stuff down here where you guys can do all the game stuff, but I've had to turn it off for this stream so that I can get through some of the code that I want to get through. I'll turn it on for the next stream. Usually I put like the AI science papers and stuff like that down there, or the science images. Those are fun, like pictures of the solar system and stuff. I can show you them on screen. If you guys want it, I'll show it to you. I'll pull it up. It's really easy. But for the time being, your commands won't work except for like tipping me, because I'll take your money. I'll take your damn money. All right. I'll take all of it. What's up, Creed? Tunnels of Doom 3? Hang on. What's Tunnels of Doom? Tunnels of Doom. What? Tunnels of Doom reboot? Tunnels of Doom. Haha, like this. Oh, I have played this. It's kind of like this, but it's all text-based, Creed. Yeah, it's all text-based. That's what the MUDs were. It was all this. This extra stuff on the right-hand side is simply some experiments for me. I'm going to merge it onto the actual game that I'm building on the browser. I'm going to merge it onto this game. So all of this work is going to get all merged in. But yeah, that's what I'm working on essentially. So all of these concepts are all going to meld together, kind of like what I've done with all my streams up to this point with like that technocracy and AI and all of that stuff. It's taken me a long time, several months, getting close to 2 years now. And it's a slow build up to the coalescing of all this information. It's exactly what's going on here. We're like this close to merging this and this together, and it's going to be quite the multiplayer and single player experience. It's gonna be a thing. What's up, Imperious? She thinks that you're a simp bitch. This cannot stand. You are, Imperious. You are. I don't know what you're talking about. Yeah, like you are. What are you? Yeah, old TI 99 game was the best of the time. Yeah, I remember playing that, but I now I remember playing that, but I don't remember what it was called. I just remember this. I just remember the picture. I didn't know it was called that. So it's more text based, but yeah. This is cool stuff. It'll kind of, well, no, not really. We're talking about something that would be your typical indie game these days here, right? So, well, we'll see. We'll merge it all together. It'll be awesome. Loaded the game from tape. Took about an hour to save or load. Yep, that sounds right. That sounds accurate to me. Yeah. All right. So the concept here that I want to do is, well, I have a problem. I kind of have two problems. So first of all, this is ugly. This is gross. It's ugly. It's putrid. It's horrid. I'm not a designer, right? I'm not, it's not my forte. And this looks better. I'm happy with a lot of the artwork that has been done for me. There's some really cool people who've done some artwork for me. I wish I could afford Emmett. I can barely afford my own bills, so I can't afford Emmett. Laughing Panda has been helping me with some artwork. He's on the Twitch side. This looks great. The thing about this though is that on the browser you have to do something called layered elements in order to make this work. Each one of these little sections in the interface here, and any website you go to, if there's a button or a form or a little input field or a little text thing here, it's an element. It's considered an element. And that means that it lives on the stack of all elements of all things on the website. And you can see there's a few elements already. You don't have to read what they are. It's a little bit small. I can zoom in, but you can just see there's a few elements. However, when I open this guy up, I have lots and lots of elements, which I'm surprised works as efficiently as it does. But we have really, in fairness, we have really drilled down on the efficiency of this thing. And we're not even halfway through it. But you can see that what I'm doing is stacking different layers on top of each other. So when I go ask the game what's at this coordinate, 0, 0, x 0, y 0, I reach down to the bottommost layer, which starts with the ocean tile, and then I work my way up. Then there's the grass tile, then maybe there's an NPC tile, or maybe there's a building here, or maybe there's like the flowers and the rocks here. I can zoom in a bit. You know, maybe it's one of these, right? Something like that. And that causes a problem, right? Because I have so many elements, and when you have something that's, say, 8 by 8 or 12 by 12 or Lord forbid 20 by 20. By the way, hey, Mystified, how's it going, man? Good to see you, Mist. That starts to add up. You have a lot of damn elements on the browser. This is one of the things that typical websites do these days. Why they're so slow? They just throw tons and tons of elements on the browser, and then they try and make all of these elements reactive to everything that's going on to you. So if you're clicking stuff, then they have to make little individual updates to all of these elements. And when you have so many elements, you have to consider what the browser has to do. If you're going to do something like click a button or you're going to change the text, the browser has to figure out if you've made an adaptation such that it has to figure out all the parent elements and resize them, right? So if you, I don't know, if you do something like change the text of a button or something, then the browser has to figure out what the width and height of that is. And then did that break the width and height of its parent, resize the parent? Did it break the parent's parent, resize that, and scale up and up and up until nothing's broken anymore? And I'm doing that a lot on this. And this is inefficient. And then at the same time, I've got, if I just do this for now, I've got this. And I thought it'd be nice to add like some graphics and just do, I don't know, something small, something simple and easy. And then as a third tertiary component, I thought it might be nice to try and figure out if we could stick to the principle of not using any graphics accelerated stuff. Like, we don't want to lean on that crutch. How far can we push a CPU to do some of the stuff we want it to do, given the amount of power we have before us? And again, all this is to make the case that someone like myself, along with chat, you guys, if you're watching now or in the future, you guys will be able to see that you can probably push it quite far, that we reach for the crutches and the hardware way too early, way too fast. There's a lot more you can do with very little. And that has implications for you as a consumer as well, because it means that you shouldn't just accept the fact that programmers think that because you've paid them for a product that they suddenly have the right to take up all of your CPU and all of your GPU and all that, and leave little to no room for anybody else to utilize those things. They do not have a right to the money that you put into your machine and all of the hardware that comes with that. They have to be they have to treat themselves as guests in your house, and they have to take up as little space and consume as little as possible in the machine you worked hard to pay for. Unfortunately, the automatic assumption in the industry today is just take up as much as you want, because people have insane hardware these days, which means that we can do whatever we like. And so that the entire premise of the video game streams that I'm doing here with a code and whatnot is to show that this is false, that it doesn't have to be this way, and that you can do a lot more with a lot less. So to that end, let's see what we can do with Canvas. Now, if you don't know what Canvas is, this will be a little bit of a nerdy stream. Canvas is something that you use to just draw pixels. Let's go, no, we want to do like HTML, Canvas HTML. Sure, W3 schools, that's fine. So a canvas is a way to just draw pixels on a block of whatever on your browser. So it's a way to draw pictures on your browser programmatically. So every pixel at the XY coordinate has the ability to receive red, green, blue, and an alpha, which is transparency or opacity. It depends on how you want to, what word you want to use for that. So when you create a canvas, it becomes an element like this, like just a canvas element like that. And I thought for this game, I would try and use a canvas, and I kind of played around with it a bit, and then I stopped because I realized I was hitting onto something that I wanted to try and show on stream live and see if we could figure it out together, because that's what we like to do on these video game streams. And I want to use it for this too. Right now, all of these layers upon layers upon layers of elements of different components on this website, which are tons, I want to compress them down so that they're way fewer. And one of the ways to do that is to remove the fact that I have to set a background image on each element, and instead take the background image on each element and stack them all on top of each other. So think about like drawing the entirety of the background image like the ocean. So if let me refresh. Let me go over here. So if I refresh and then I go over to the ocean, that's the background layer. So I want to start with that first. Then I want to do the grass over top. Then I want to do, maybe the road over top of that, the building, the rock, the plants, and then I want to do the NPCs that are moving around over top of that. And I want to see how far I could push this thing if I was to take this canvas element and render it every frame, render all of that, instead of grabbing images and background positioning them and slicing them off and stacking them with a bunch of elements. And so if it's an 8x8, we're talking about 64 elements per layer. If you're talking about like 4 layers, you're talking about 256 elements. That starts to scale up and get crazy per frame. You start to do all kinds of stuff. And I'm just thinking, like, what if it doesn't have to be this way? What if I could make it so that I knew I could be smart and intelligent and clever about the way that I'm rendering the graphics here, and that I render some graphics here. Thought I'd use this page as a test bed for, I'm not sure what, honestly. We're just going to try and figure it out. That's right. Deport them all. That's right, Creed. Deport them all. Oh my God. How you doing? Good to see you. Welcome in. Okay. So how this is going to work is we're going to take a canvas element like this. And then what I need to do is I need to read the specs on the canvas element. Typically what happens in a browser is if you're running a canvas element, it's going to get graphics accelerated. It's going to get a GPU acceleration. It's a 3D acceleration, which means it's going to offload the rendering of any graphics onto your graphics card. And of course, that's really, really powerful. And I had a thought about this. I wonder if we could test this. And as I was thinking about this, I was reading the specs, and then I came across something, and that's the point where I stopped. Let me see if I can find the correct specs. width, most opaque, blah, 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 canvas, yada, 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 off-screen canvas, yeah, get context. Where are the attributes? Canvas HTML, what? Maybe it was off-screen canvas? Let me look at off-screen canvas. Off-screen canvas. Height, width, get context, convert, transfer image, context lost, context restored. Okay. Yeah, I don't want WebGL. That's hardware accelerated. I want I saw this. What was it called? HTML canvas, CPU only. No, I don't want the AI or thing. Optimizing canvas. Canvas CPU benchmark. How? Oh, what's this? Actually, I haven't seen this. What's this? Canvas CPU benchmark. Things I learned while developing visualizations in the HTML canvas. Okay. How fast can you write to a canvas pixel by pixel using solely the CPU? Perfect. I didn't even see this. Okay. 1 pixel at a time. Instead of writing every pixel 1 channel at a time, it's more efficient to write once per pixel using a clamped array. Okay. Ah, okay. That makes sense. This has a huge impact on performance since gains scale with the number of pixels. All right, so we would just have to figure out what that buffer is. Avoid calling getImageData. All right, that's fine. And then ran some tests. Okay, but there's an attribute to this. This isn't exactly all it is. There's an attribute that will do like a will read only, or only will read or some. I don't know. Okay, I'm gonna keep this up because this one's handy. But let me do read. Read. Nope. Okay, this one's staying up though. That's fantastic. It's CPU HTML canvas read CPU read only, I think is what it was. I don't know, is it in here? Read. No, it's not in here either. Bros, I swear I saw this. I promise this, I swear. By the okay, I can't sing the whole song, I'll get dinged. Read? What the heck? Bros, did I set up this whole stream and I hallucinated the entire thing? Disable or set read-only HTML5 canvas. Chrome okay, get image data. Okay, hang on. Let me pull up my, I'm not going crazy. Let me pull up my history. There's no way I'm going crazy. It's not possible. It's just not possible. I'm not seeing it. Am I searching it? Okay, it was will read something. Let's just, okay, let's do this. HTML canvas will read. Is it will read frequently? Damn, that's what it was. That's what it was. Ah, okay. We got it, boys. We got it. That's what I saw. Okay, will read frequently. Whew, for a minute there, I thought I was hallucinating like an LLM. Will read frequently is what it is. So will read frequently, a Boolean indicating whether or not this canvas uses software acceleration instead of hardware acceleration to support frequent read-back operations via getImageData. So the idea behind this, will read frequently will tell the canvas element. It'll tell, not this. It'll tell what? Wherever the W3 school's here. It'll tell this guy, whatever canvas element this is. that you're either going to read the output of this data frequently or you're not. And as far as I can tell, let's just do a will read frequently kind of, search here just to see what this means. Will read frequently, Canvas 2D. So it will get read. Yeah, it signals that this is a canvas that will get read directly a lot. There's an important use case for apps and games that are very reliant on get image data. The operation is particularly slow when Canvas 2D is backed by accelerated graphics, like your graphics card, that speed up considerably most other use cases. Historically, browsers have tried heuristics to decide if a canvas is being read frequently or not to switch code paths. This is unreliable, complex, and brittle. To prevent this, we propose a hint that tells the browser this will get read frequently. As a result, what you want this to do is to have a slow rendering time. So this will be a GPU-based rendering of some kind of graphics that's going to be slow because you're taking it away from the hardware acceleration. You're removing it away from the graphics card. And instead, you're going to read it a whole bunch of times. Now, that's perfect for me because if I take this game and I dump out the HTML and re-inject it every frame, I'm going to want to do a bunch of reads on a canvas when I generate pixels. So if we just play around with this on here first as our test bed, because this game is our test bed for multiplayer and graphics now, it's going to be graphics now, and messaging back and forth and all of that stuff. And we're going to start integrating it in here. This is going to be perfect. We're going to see how this works. So the assumption here would be that if I enable will read frequently true here, just like this, then I'm going to be able to test two canvases. One canvas will be GPU accelerated, so I'll set this to will read frequently false on purpose. And then another canvas will be will read frequently true, and I'm going to run through a bunch of operations of drawing on those two canvases, and I'm going to see which ones do read and writes more. So to that end, I am going to pull up some code. So this is my local, which means I should be able to pull up this guy. Yes. Okay. This is my local code running this game. And in here somewhere, maybe here, script source, canvas. You know what? I want a different color scheme today. Metal gate. Oof. Flashbang. Hacker green is good. Blue white is. I'm kind of feeling hacker green. Yeah, I want hacker green. We're going hacker green. Okay, this is going to be canvas.js, and then in here I want to have. Well, let me just check something. Is it off-screen canvas that I want? Can I use off-screen canvas? Off-screen canvas will allow canvas drawing to occur with no connection to the DOM, can be used inside workers. This would be ideal. I mean, I guess I don't really have to worry about older. Is this a crutch though? Like, am I kind of defeating the purpose by leaning on this crutch? Yeah, kind of am. But do I really need to do this anyways? Okay, I don't need to decide this right now. What I don't want to do is I don't want to use an off-screen canvas and then find out that there's some kind of like extra boost that I get out of this that I didn't really want to use, because the whole point of this is to not lean on anything. I'm concerned. Okay, I'm not going to do this. What I'm going to do is I'm going to put it at the bottom of this guy. So let's try this out. If I go over to network, I want to know that Okay, Canvas.js does not exist, so let's create it. We're just gonna go like this. Canvas. We're gonna say Canvas.js. There it is, and I should see Canvas here. I do. Perfect. We're off to a start. So ideally what I would do is I would want to draw a whole bunch of canvases. So usually what you're going to do is create 2 canvases. Yeah, just working in HTML. Yeah, Creed. That's it. So Creed, just so I think you're new here, so you don't know what I'm doing, but you know about the AI stuff because you've seen me debate about that, I think. I'm pretty sure you have, Creed. And the premise, the underpinning of all that is that the tech industry does not know how to write anything quality anymore. And they lean on crutches like hardware, and they think that that HTML is slow. They think that the stuff that we've had on the internet for the last 30, 40 years isn't good enough anymore. Websites like, by the way, websites like this. Here's Amagod's website, amagod.neocities.org. Here's another one by Sophie72. Here's Fireslinger by Travis Roman, who's an amazing programmer. In my opinion, he's the best programmer that possibly exists on the planet. There's Gare Games here, another incredible programmer. This is just his website. He just wanted to build this one. Here's one from TMX, who's transcribing my videos and then creating plots, like data connections between all the words that I say, right? The deep word, or sorry, the important words, so that we can do things like when we look at like what meta is connected to based on my words, you can kind of see that, right? He built one like this. Here's Laffily, who's building his own Pico 8 games, which is just a fantasy video game console emulator. So these kinds of websites, people think like it's stupid. No, it's not stupid. These websites are incredible. Go to neocities.org and go make a website. Absolutely, it's free. Go make a website. Just make just whatever website you want. This is the way that the web should be. This is the way it used to be. And we went away from it because there were definitely some issues with creating websites like this. But this stuff is cool AF. And we need to get back to this because we have zero excuses not to have. No, it's good, Creed. It's good. We have zero excuses not to go back to this. Anyways, I wanted to bring this up because like NeoCities is awesome, and I shout out people in the community who are building websites. We're going to be building a game that pieces together all of these websites, and everybody who's built a NeoCities website and tells me about it, I'll make sure to give you a shout out. Here's like Emmett's pixels here that he created for, oh my God, this is great, right? Go build a website like this. This is incredible. Go to NeoCities and do it, and then you can type in Discord, !Discord, all one word, in any one of the chats that you're in, and you can get a Discord link out to my Discord and come and tell me about your website, and I'll shout you out just like I did now. And we're going to merge all these websites together. If you want help building it, ask on Discord. I'll help you, or somebody else will help you, etc. So anyways, Creed, back to the summary. The point is that people look at HTML today, especially programmers and dumbasses like tech influencers. I'm going to talk to somebody tomorrow. I'm going to interview them about some drama where they completely obliterated a bunch of people in tech who are supposedly creme de la creme of tech. They are tech influencers and tech streamers, but they couldn't be dumber when it comes to tech. They couldn't be more stupid with regards to tech. They might be intelligent people in other aspects, but how they made it to where they are, I have no idea, because they're not real programmers. They are soy boy, weak-ass programmers who have no balls. They are code cucks. All they do is they just take other libraries and frameworks and languages, and they make them handhold their own code. That's all they do. They're just code cucks. And they think that they need to do that because websites apparently need to be complex today. No, they don't. Most websites require very little, and they most certainly do not require stacking on layers upon layers of complexity. So they avoid doing what I'm doing here. They avoid doing the pure HTML. This is pure HTML, vanilla JavaScript, vanilla CSS. There's nothing going on here. There's no third parties. I hand roll all my code. I write in C, compile to WebAssembly. Everything is hand roll. I I use nothing external. They're script kiddies, yeah, but they're the most influence. They're the most watched influencers, and they have investments, and they work at Fortune 500 companies and all of that. And what's the result of that? You get ads and subscriptions and buggy websites and bloated software and games that suck and don't run performant and look crappy and all of that stuff, right? But this is exactly why, because all they do is they reach for pre-solved solutions because it's an appeal to authority argument, which is an authority figure has already solved a problem for me. Why should I figure it out myself? And I go completely against that on these streams. So to your point, Creed, yes, this is all vanilla HTML. And that's why when I look at something like off-screen canvas, right, in order to generate some pixels, right now I'm using images. These are just like J or pings. These are just PNG files. And I just slap them on top of an HTML element, and I background position them. And then I layer them over top of each other. But what if I wanted to use the canvas? Is the canvas actually that slow? Because a lot of people think it is. A lot of people think the canvas is slow, especially if you don't have hardware acceleration. But man, what a crutch to have however many gigs of VRAM, video RAM, or virtual RAM, or whatever it is for graphics cards. I think it's VRAM. 16, 32, 64 gigs to render the most basic crap like this website, or like this website. That's insane. You don't need that. Or this, you don't need that crap, right? So I look at off-screen canvas and I wonder, because it's a bit of a newer one. I remember this came out not too long ago. I am concerned that I'm going to be leaning on a crutch, and I want to step away from that. I want everything to be as dumb, considered dumb by the normal occurrence of programmers as possible. I don't want to depend on anything but the most basic things, because hardware is indeed so powerful, and I want to utilize as little of it as I can on your machine when you go to play this game. So I'm going to avoid canvas. I'm going to avoid, off-screen canvas. I'm going to take this guy, and we're going to enforce the will read frequently true. So this should put us in the operational bounds of the CPU. And then I'm going to create another one, and it's going to be false. And we're going to set these explicitly. And I think what I should do, I hate const. Just do var. So this will be CPU canvas, and this will be, we're going to say GPU canvas because that's usually what it defaults to. CPU context. We have to go like this. We have to go like this. All right. So we have two canvases, and I think it probably behooves us to put them into the, do I want to put them in the body? Let me think here. Well, I'm gonna end up doing it one way or another. It might be better if we assumed a premature optimization, rendered images first onto the canvases, then dumped them into the body, but took the performance for, okay, I got this. So at some point we're gonna want to put them into the browser to see them, right? So we'll go CPU canvas, that's document.body, and then GPU canvas. Now the next thing that we want to do is set their width and height. So if we're going to do that, then we have to take the I'm trying to remember. Style doesn't work. Canvas styles don't work. You have to set the attributes. So I guess we'd have to do this. We're going to go CPU canvas width 1000. Yes. And then we'll do height. Yeah, and then GPU canvas. Okay. So now we have two canvases, 1000 by 1000. One is CPU only, one is GPU. And the GPU one might get some benefits out of the CPU along with it, but that's fine. That's what we want to see. Now what we want to do is we want to draw a bunch of stuff on these, like a ton of stuff. And then there's a thing that you can do in the browser. It's called performance. Yeah, performance now. Get out of here. Yeah, here we go. Web API. Performance.now. This is going to be just a timestamp so that you can see how much time it takes. Yeah, how much time it takes to run something. So if I go back to, well, let's go back to this. If I go performance.now, and then I go performance.now, it's going to be, and then whatever the difference is between these two timestamps is going to tell us how long it takes to do something. So essentially what we're going to want to do is we're going to do like function test draws, something like this. We're going to do a bunch of drawing. First we're good. Okay, yeah, we're going to do this. We're going to go performance now, CPU drawing. And then we're going to go performance now, GPU drawing. And that'll be the first like test, is the draw test. And then we're going to have a read test reads. And the reads are for get image data. So if I go back to this, we're going to go performance now, get image data CPU, and then whatever it is, like that. And then we'll do the same thing here, except we're going to go GPU. And so what we're going to test for is the difference between getting the data out of these canvases and putting data into them. And we're going to see the difference between the CPU and the GPU one. And hopefully this test, if we do enough iterations on it, will give me some indication that confirms that the CPU or GPU bound tests are actually working the way that I expect them to be working, if the specifications are correct. So to do this, we're going to want to come up with something for drawing. The get image data one is pretty easy. We could do that one really quickly. So if we go back to get image data, I think we have to get it out of the context. Get image data. Oh, right. You have to do starting position, width and height. That's easy. And visit the context, draw image. Yeah, context. Yeah. Okay. So this is what we're going to do. All we're going to do is go CPU context, get image data. Oh, come on. Get image data like this. We're going to start at 0, 0, and we're going to go at 1,000, 1,000, like that. So that's going to be for the CPU. That's going to be for the GPU. And probably what we should do is do a diff, I suppose. We'll go var start end, and then 0, and then var CPU diff, and then var GPU diff. We'll do start end, and it's going to be CPU diff equals end minus start. We'll do the same thing here. And GPU diff will be end minus start again. And then we're just going to spit it out just to see how far we get with this. Probably would be good for us to not do this right away, although I don't see why not. No, we got to draw first. Let's do the draw. Okay, so we just got to come up with a draw algorithm. We have to draw first, then we have to have something to extract. So otherwise, we're just going to be extracting like a bunch of blank pixels. So if I run the test right now, it's not really going to give us anything except just letting us know it worked. But let's just finish it. Let's just go all the way. You put minus instead of equals n. Did I? It seems okay. Yeah, it seems okay. Second to last one. Yeah, no, it seems fine to me. What's up, Abe? Good to see you, man. Yeah, the GPU diff will be end minus start, and the CPU diff will be end minus start equals end minus start. Yeah, it seems okay to me, still, man. Ah, it's okay. It happens sometimes. It's hard to read it on screen sometimes. Abe, I hope you're having a good night, brother. How you doing? What's good, Spidey Spirit? Not much, man. Not much. I'm just geeking out over here. Geeking out on performance metrics and stuff like that. Yeah. Okay. So if we're gonna draw a bunch of stuff, um, what are we gonna do? What are we gonna do? I'm trying to think here what I want to do. Testing the draws would require. Okay, I think I know what I want to do. We're gonna do this again. Start, end, start, end. We're gonna want to do the CPU and the GPU diff again. Exactly the same thing. We start with that. We'll do that. We'll do that. Change it to CPU, and we'll console log out the CPU and the GPU. All right. Now for the drawing, I want to draw a certain number of iterations. Like, I don't just want to draw one thing. I want to draw a bunch of things. And I probably want to do something like iterations. And we could say 10 to start with. Okay, so we're going to loop through iterations. We're going to start with 0, and as long as 0 is less than 10, we just continually increase 0. Laws of logic, super simple. And as we increase the iterations, we're going to draw something. And in order to draw something, you have a few options. You could like put image data in there. You could draw an image like that. There's other ways you can draw shapes. Let me go back. You know what? Let me just search for it. Canvas, like draw, I don't know, like draw a circle. Circles are usually pretty, yeah. Here we go. Arc XY. Okay, so why don't we do that? So essentially what we would do is we have to start with, well, in order to do this, I think there's a path you have to set. Yeah. Path and then the stroke. So you have to begin a path, then you have to create your circle, then you got to stroke it. Stroke it to completion, all right? So we're going to be stroking paths to completion. We could fill them, which actually probably is better. We probably actually do want to fill because that means more pixels, which means better test data. And we have to consider the fact that it's a 1000 or yeah, 1000 by 1000. Okay. CPU CTX begin path and stuff here. CPU CTX fill. We're going to fill it. And then in order to do this arc thing, we have to determine the X and Y coordinate. And then we have to determine, what was it here? X, Y, we have to determine a radius and then the angle. And counterclockwise? I don't think I want to do. Okay, so let's do this then. CPU CTX, and then we're going to go arc, and then it's going to be something of 1000, some kind of like radius, I guess, here. You know what I could do for radius? Math random. And I could just set the radius to like, I don't know, something like that, right? Like it doesn't have to be crazy. The start angle and the end angle. Zero as a start angle. And Math, JavaScript, pi. Math.py. You know what? Math.py. That's it. I think that's what it is. Because you want to do pi times 2 to get a full circle. So it's just that. That's what she said. Yeah, that's what she said. What's up, Lightspeed? You went to pay for Testers Community. It was Razorpay, which is an Indian company. So I got paranoid and opened network tools and saw 666 runtime. What do? You go call up your local priest and you get an exorcism, Lightspeed. Alva on YouTube. What languages am I coding? Vanilla HTML, vanilla JavaScript, vanilla CSS, vanilla C. No third-party libraries, no dependencies. Literally everything is hand-rolled, including any standard libs, Alva. Okay. So that's fine. The only thing here is this is going to be a 1000 over 1000 and it's going to constantly put in the same set of pixels over top of each other. I don't really want that. So I think it's probably better if I randomize this times, yeah. Yeah, okay. So let me do this so it's a little bit easier to read. So we've got X and Y, we've got radius, and then we've got start angle and set and end angle. So this should make a full circle. This should give you some kind of random radius, I suppose, which is like the size of the circle. So you will get different sizes per iteration. And then this will just be a random starting point location in the canvas to start plotting it in. That's what it should be if I did this right. And then in order to do the fill, I'm going to have to do something like some kind of like random color, I suppose. Well, I could pick I guess I could pick a color, but if I want like canvas fill here, canvas fill style, that's what I'm looking for. Fill style. Perfect. Perfect. Couldn't be easier. So now we're going to go CPU context, fill style, and it's going to be red, green, blue, RGB with an alpha, and we can always just set that to 1. Red, green, blue can be, we'll just do the same thing. Random, I think it's 255, I think. Yeah, because it's 256, that's right. Math.random 255, and then math.random and 255. All right. So hopefully that gives us our fill style. Now we're going to fill it. So we're going to do this however many times we set it to do, which is iterations. When we run the test draws, we can set, we'll just start with 10. And then we're going to copy this and essentially do the exact same thing, but for the GPU. And if I'm smart, what I'll do is I'll go like this. Var CTX is equal to null. We'll start with CTX equals CPU CTX. And that way, it's going to make it easy for me to copy and paste this code and make changes to it. So we'll do this. We'll do this. We'll say like do the draw. We'll figure this out in a second. Function do the draw. We'll put that in here. So we have start, end. You know what? We can just do this now. We can pass the context in here. It'll be, so that way it'll be the exact same code, and then we're just going to return this. Perfect. So now we can just pass in, yeah, that's much easier. Much easier. We don't need that anymore, and we don't need this anymore, and that's it. Now, iterations will have to get passed here as well. Okay. And now we just have to do this. Oops, oops, oops. Stay in school, kids. Don't be like me. Oh, man, definitely don't be like me. GPU context. Perfect. Okay, so now it's going to be consistently the same with both. If we fix a bug in one of these, we'll fix a bug in both of them. I don't like the indentation. That's bothering me. It's just my own personal little thing. It's just bothering me personally. Okay, there we go. All right, so now we have the two diffs. We have the two sets of iterations that we're going to run together, and then we're going to spit them out. At this point, is there anything else I need to do? I don't think so. Testing reads, just so that I know which one's being tested. Testing, we'll call this writes. I think that's it. Too late, I'm already like you. Damn, missed. Damn. Okay. If I go to... I think it's this guy. I see the canvas. Okay, so this empty space is indeed the canvas. And here are two canvases. Sweet. What I'm going to do is pop this out so we can see the full thing here. And then what I'll do is over here, I should be able to run. Let me just make sure I get the... So first I want to do test draws, and then I want to do test reads. And actually, this should also be iterated. We actually want to do this as well. Because if we're going to do an animation frame, if we're going to do every frame, we want to read this to figure out, like, you know, how fast it's going to be or how much we can read it. We have to iterate on it. So again, this is going to be I is less than iterations plus I. We're going to do... Well, I suppose we're going to do this, aren't we? And this. And... Actually, no. Put this on the outside. We're going to do... So, okay, there's two ways to do this. This is why benchmarking is kind of annoying sometimes. Crap, hang on. So there's two ways to do this. So on the one hand, you can track the entirety of all reads and writes, and then take the difference of that. So this is what we're doing right now. We're taking the entirety of all reads and writes and just all iterations, and then we're just taking the difference between them and seeing that. That's going to give us a sense. There's another way to do it, which is every single read and write, and then you average it and or mean it out. So depending on the kind of benchmark you're after or the statistics you want to see. But right now, this is fine. We just want to see that this works, first of all, and we want to see if there's enough of a difference, enough of a variance to give us the indication that something is happening better on a GPU than a CPU. And if we're right, so let me refresh. If we're right, what should happen is we should see when I run test, what is it? Test draws. When I run test draws here, we should see the GPU one be much smaller in terms of time difference between the performance now than the CPU one. The CPU one should take a lot longer. Then when I do the reads as a follow-up, then the CPU one will be better and the GPU one will be worse. So hopefully that's what happens. And of course, fill style is not a function. You know what? It's not a function. Shut up. It's a CSS style. Shut your mouth, okay? Shut it. Shut your mouth. That's what I have to say. So if it's a CSS style, then it has to be, we could just do this. Just keep it simple, and we'll go, I guess we have to go like RGBA, I suppose. And then, do I need to wrap this? Do I need to wrap? No, I think this is fine. Yeah, okay, let's try this. Oh. Oh, did it work? No. Yeah, look at that. Sweet. We did it. Okay. So the CPU for drawing took, Can you see that? You know what? I should write better outputs for this. Let's just clean up the outputs, and we see an immediate issue. Yeah, well, not an issue. This is confirmed. CPU drawing took CPU diff, right? And then GPU drawing took GPU diff. And we're going to do the reading like this. And we're just going to say GPU, CPU reading like that. And then we'll run this one more time. We're going to go like this. Sweet. Okay, so have a look at that. So the CPU drawing takes way longer than the GPU drawing. And then if I do the reading, yeah, CPU reading, way faster because the GPU is not intended to be used for reading. As a matter of fact, it's actually quite the disparate. So subsequent draws don't take as long, I guess, because you have pixel data in there already. But let's try. Yeah. Yeah, I mean, in some cases, it's so indiscernible what the GPU does that the CPU will go almost to 1 and GPU will just do nothing because like the number is just so non-decipherable. Now, if I wanted to, on each iteration, what I also could do is clear rect, I believe. CTX clear rect, and then I could go 0, 0, 1000, 1000. I don't think this is going to matter. But I don't think I want to do that. I think I want it to get filled up. And I want to up the radius. So let me do that. I'm going to do like 150 or something. Let's make this really big. Yeah. Yeah, man. Okay. I don't even think we need to test this much further. Look at that. Look at that. So what's crazy to me is that even with hardware acceleration turned off, there are subsequent writes to the canvas. This is super interesting, that are almost equivalent to the GPU in some cases, which means that you actually, instead of getting diminishing returns, you get better returns overall. The more you draw to the canvas after the initial draw, sometimes you get something that's equivalent to the GPU. That's crazy. This isn't like a definitive benchmark, but okay, now if we do reads, yeah. And the reads is where it really shines because the GPU cannot read this crap. That's not what a graphics card is meant to do. A CPU is meant to do this, but a GPU is not meant to do this. Look at that. Nice. So all this just to tell AI to shut its cuck holster? Yeah, that's right. All this to tell cucks to stop code cucking. Stop being a code cuck. More dots. If the CPU is under load, though, you might have differences between CPU and GPU. You're right. So I would wonder, yeah, you have a point. So okay, so let's just see then. What we could do is go like, okay, I have an idea. What if we ran the CPU on 100 times and each time it did 10 draws? So we're testing an iteration of an iteration to put in a load, to kind of fake the load, right? Let's just try it out. Test draws. CPU, GPU. Yeah. It's still way more. 0.3 versus 0.09. That's considerably more. Let's crank it up. Iterations will be will be 1,000 and 100. Let's crank up the rates. Oof. Well, that's interesting. What the hell happened there? How did the GPU take longer? Guys, this is wildly inconsistent now. Shit. Shit. Well, I don't like this now. What if I do this? What if I crank up the iterations outside, but take down the iterations inside? Not enough. So you do have to have like, you have to have something. Maybe let's do 20. You have to have enough for it to be counted, if you know what I mean. Like, that's going to take a hot second. Odd groups to the left, even groups to the right, you lose 50. Yeah. This is going to take a sec. Hopefully my stream doesn't crash while I run this. What did I set it to again? 20 and 100,000 loops. I don't know, man. This is taking a while. So maybe the drawing is kind of a wash. I'll let it finish. I want to see what happens if I crank the reads, though, because the reads should be consistent. Oh, there we go. How long did it take? What? How? Okay, let's take the reads. Are the reads going to show that the CPU still wins? I hope. Because ultimately it would be the reads that would get called every frame. What will happen while this is running, let's go back here. What's going to happen in this game is you're going to load the game up and it will create a bunch of the images in the canvas first on load. So that initial load, whether it's run by the CPU or the GPU, you kind of only incur that cost once. I'm less concerned about it, although I am still concerned. It's the reading, because every single frame, so if you're doing like 60 frames a second, you're going to want your read to be the best. So hopefully this shows us that the reads end up being the best on the CPU. I'm shocked by this. Is the CPU doing branch prediction maybe? Maybe because there's like a whole bunch of branch prediction? I'm not sure, but those reads sure are hefty. The GPU should not be able to read this performantly. It should never, ever happen. It should never. Not once. Not even once. Unlike Bill Clinton. Not even once. You know, when it comes to Monica Lewinsky, Bill Clinton, just the one time. Okay, here we go. Yeah, that's what I expected to see. Okay, so 100% confirmed. There's little doubt in my mind, especially if you look at what GPUs and CPUs are intended to do. GPUs are not meant to read stuff. CPUs are meant to read stuff. That's the CPU's like thing. It reads and crunches. GPUs don't read and crunch. GPUs do rendering. It's a different world, right? So I should never ever see this. And so far, we have not once seen the GPU beat the CPU on reads. But I am concerned about this draw stuff. Gravely, gravely concerned. Let me take this down. How did the CPU take nothing? And what? Bros, there's some branch prediction going on. That must be what's going on. The CPU has like a hot path. Um, okay, if I take down this iteration and I crank up this iteration, no, bros, no, there's no way. There's no way the CPU is hot pathing faster than the GPU. No, man. Don't, no. Lies. Lies detected. What the frick? It hot pathed it? All right, let's switch it up. Let's go 100 of these and like 10 of these. What the? Shut up. Bros, am I going to be writing to the CPU? Am I going to be software rendering the entire game? Okay. I don't know, man. I don't know. I think what's happening here, I think this is bad. I think there's an optimization happening here, and it's hot branching. The CPU is trying to detect the path of least resistance, and when it sees repeated calls to this drawing thing over and over again, it hot paths inside the hardware, which branch it has to go through, and I think it's hot pathing it through the CPU, and so the CPU is getting a bit of an advantage. JavaScript lies to you and still uses GPU. I mean, it could be. The specs could be wrong. We're talking about browser specs here. If this was the case, then you'd be hearing about it. People would have complained about the browser not following its own specs because these are browser specs. This isn't like this is built into the JavaScript core browser specs. So if it tells you that it's CPU bound, it damn well better be. This isn't like a JavaScript library, or a third party where, a famous tech influencer could tell you whatever he wants and cuck his code while he sits in the corner watching another library handle and manhandle his code, pet it and massage it and treat it nicely, doing all the things to it that he knows he can't do to his own code. This is browser spec stuff. So I would think that if this wasn't working, people would be complaining up in arms about it. It is only reading one and making the output random, so kind of just bad code. That's yeah, Creed. That you're kind of like you're kind of saying the same thing I'm saying, which is the code is kind of bad. It's not bad. It's just bad because it's predictable. That's the problem. And when something's predictable, what your CPU, not your GPU, as far as I know, anyways, your CPU likes to go and find repeated patterns, functions, or things that you do over and over and over again, and it likes to hot path them. Of all available options in a system or in a piece of code, which one is the one that is run the most? Let's make that the most likely outcome and get that prepped in advance. And so maybe the CPU is prepping this in advance. Like, Um, what if we what if we did this? Um, what if we did Oh no, I don't want to do that. That's so weird. Okay, let's just change it willy-nilly just for a minute. Just for a minute. I just wonder if changing this has any, you know, yeah, like I want to try and cache bust it. Do you know what I'm talking about? This is something you do on the web where you, um, yeah, that might as well. Where you cache bust whatever your, I think this should be, yeah, and then this height. Let's just try this for a second. Why is the GPU taking longer? Not constantly, but what the hell? Um, maybe it changes mine here, Ernesto. Yeah. Branch prediction exists in the GPU even more than the CPU. Does it? Creed, yeah, I'm not saying you're bad, just hitting one, barfing out the other. Maybe, yeah. On Windows GDI plus cache, maybe, yeah. GPU does even more aggressive caching for branch prediction than the CPU does because of the vector processor. Is that true? That's why I said um I wasn't sure. I did qualify my statement. As far as I know, that's what I said, right? So it might be that I'm going to learn something about the GPU. We're going to go look this up. Fuzzy, thank you. What kind of nerd shit is this? Arakar, get the hell out of here. Get out. You don't belong here, Arakar. This is for people with actual intelligence and IQ. Okay? All you do is bash pixels together. All right? Which is definitely not what we're doing here over and over again in an algorithmic repeated process. We're making art here. What do you do, Emmett? Emmett, what do you do, if that's even your real name? How can anyone pretend to make a game? Oops, because it's context. Switching more than the CPU is because it has more parallelization possible. Um, in my area of expertise, we have feelings and stuff. How does this color make you feel? It makes me feel angry at you. Okay, fuzzy. GPU branch prediction because I don't actually know about the GPU. I know about the CPU. That I know about. Graphical process unit. Well, this doesn't have anything, does it? Okay. Um, GPU. Why is there no Fuzzy, do you have any information? Like I want to read it. I want to read this because this is super strange that I cannot count on this test to give me a graphics card output. So I'm in the wrong spot. I'm not smart. That's right, Creed, get out. Arakar, get out. Creed, get out. Chief, get out. Fuzzy, you stay. Because you seem smart, Fuzzy. The GPU has thousands of things that can do concurrently in parallel, where is even a 9950X can only do 32 things. I see. So the branch prediction, oh yeah, okay, that makes sense. The branch prediction on the GPU would actually do more branch predictions because while a CPU will do things imperatively, a GPU will do things simultaneously, concurrently, side by side, and it has to branch predict all of those things. So in a way, I think I see what you're saying. Um, so it's the amount of throughput that you get in your GPU versus the CPU, and it's context switching between all the factors, and it's not able to cache, right? So it has to branch predict all of the time because it can't cache, it can't hot path it, whereas a CPU can hot path, right? Because that's kind of what a CPU is it taking context and it's figuring out which path in your machine is being run the most. What's up, Istami? And um, and then it's like caching it essentially. That's what the caches are on the CPU, the different like L1, L2, L3. But a GPU is different because it's about throughput, where like you don't necessarily need the cache anymore because it's just about how much you can shove through it. So, but I want to read. I want something, you know. a branch prediction on GPU. They do prediction with branches. Cora says you're wrong. Exactly. Vector has its own cache. Right. Cora says you're wrong. Branch predictors are pointless in contemporary GPU microarchitecture. They don't serve a purpose. Branching on a GPU. Oh, here it is. GPU handles branches the same way vectorized CPU code does, scalarization. Your code is being linearized into a linear stream of vector instructions. Yes. Or yeah, Aurora. Yeah, Cora is worse than Stack Overflow. So let's just read this. Arcar says my pixel meshing is superior to your pixel algorithm mess, but I guess you can do while statement and do it until it looks okay. That's right, Arcar. I'm building my own LLM live. I'm doing my own LLM live, Arcar. Deal with it. Whoever just gave me a follow, I appreciate it. AJ at Jaheel, thanks for the follow just now. I appreciate that. Okay, let's see this because I want to try and understand what the hell's going on here, because this is a problem. If I'm going to try and create the pixels in this game using the canvas and prove that it's like fast and efficient, but my tests are showing that the GPU and the CPU are switching between their ability to performantly render the canvas, I have a problem before me, which is I got to pick one. I have to pick one. And I'm inclined to pick the CPU because if there are some times when it's as fast as the GPU, maybe because the branch predictor on the CPU hits like the same kind of branch prediction on the GPU in certain cases, maybe it's just okay. Maybe I'm just actually like optimizing a bit too much and I don't need to worry about this, but I'd like to read up on it because I haven't read up on GPU branch predictors. And it makes sense that if you have vectorization on GPUs, then it's going to be like vector branch predictors. That makes sense. The second component is what kind of code is in each branch. Hang on, what's the first component? The first is what data is being branched on. If it's a constant buffer, then branching can be cheap. This is because the compiler knows the branch will go the same way for every pixel or vertex. Damn, okay, now this is making sense. Fuzzy, bro. Thank you, man. This is making sense now. Yes. The branch will go the same way for every pixel or vertex because constant state buffer is guaranteed to be constant for every pixel or vertex being processed in parallel. But if the data is dynamic, say a value from a texture, then each pixel being processed together in parallel, that's the key thing, in parallel. Because a CPU will not do that. That's what you were talking about, Fuzz. Whereas a GPU, it's about throughput. It's like a bigger pipe where you can shove more data through it, and it's gonna be able to handle doing more operations at the same time. So it's the parallel stuff that it needs to branch out in the process. So if you have dynamic pixels being processed together in parallel, now you have to do a different kind of branch prediction, because it depends again on the kind of data that goes in there. It can decide that a proper branch is needed when the code in each path is small enough that it will execute both sides and pick the result. When it's divergent, other optimizations can be broken. We avoid branches on noisy signals that change every pixel. That makes so much more sense now. Yeah, okay, lots of pipes versus bigger pipe. That's it. Lots of pipes versus bigger pipe. Yes, that's it. Okay, so the second component is what kind of code. If you're going to sample textures, you need to use gradients, especially you need to write your code like this. You put on a float. Sample texture 2D gradient. Okay, this is a Unity thing, I guess. To maintain the 2x2 quad optimizations GPUs perform. You'll even get compiler errors, damn. Okay, so the reason why it's doing this, I think I understand. It's because it has to determine what the texture is and how it's going to, get out of here, how it's going to utilize it. And then you can do a branch count. Okay, so it still does branching, but it's actually kind of fundamentally somewhat different. Unfortunately, what I think this means then, is that we're no longer talking about a raw GPU, CPU access here. And I think it was Creed on, I'll leave nonetheless. You can keep messing with your girlfriend and being your ex. Shut up, Erikar. Thanks for popping in, Erikar. Appreciate it. So I think what this means is that because we cannot get a consistent set of stats, right? because it's not consistent. Branch prediction misses are way more expensive on GPU. Yeah, right. Because when you have a branch prediction miss on a GPU, what you're essentially saying is that you have possibly missed you've actually possibly missed an entire set of concurrently running processes, because sometimes it has to switch between all the things it's running at the same time. So and then even if that's not the case, let's assume it's just one thing. What you have to then do is go back and potentially recompile and remap a bunch of steps that got you to the point where you had to do a branch prediction in the first place, because you have to go back to the beginning and factor in location-based things like UV mapping, like your vector coordinates. All that stuff has to be refactored in to determine which branches are available to you at a certain point, and then repredict those branches. So yeah, it would be a lot more. Yes, there you go. You have to unroll an entire stack and start over. Yeah. Yeah. So what I'm wondering is if there's some kind of weird mixture where, depending on what you're doing, see, that one took longer. Some of these are taking longer, but then some of these are not, right? Like that one's almost exactly the same. No, it is exactly the same. How? Tell me how. Is my code wrong? Am I tracking start and end wrong? No. No, these would be locally scoped. These are all locally scoped. I'm not overriding any of them. I'm not doing the reads. No, this is all fine. How on earth do you get the exact same number of seconds for both? So, see? What? No. And then the GPU takes way longer. Bruh. Oh, this is weird. Something's up here. No, var's not global. Var's not global. It scopes to the function. It's only global if you go from the outside in. It's not global if you go from the inside out. And I'm not doing anything from the inside out, nor the outside in, actually. So I could even just do like let. If you do let, that is supposed to confirm locality, but it comes at a cost. The var is heavily optimized because it's been around forever. Let's just see. So the GPU drawing took way more. Then less, then this exact same, then the exact same. This number keeps popping up all the time. Then a little bit more, then more, then more, then almost the exact same, exactly the same, then more, then more. Yeah, something's not right. There's some kind of mutex locking access to canvas you don't have control over. That's what I was going to say, is that I think there's something happening in the browser, or maybe even the JavaScript engine, that I can't control, that's affecting this. Maybe they're trying to do performance optimizations with canvas, with the JavaScript engine, with the GPU acceleration, and that's what's happening under the hood. Try drawing to a buffer and then copying the entire buffer back over to the canvas. Okay, so if I did that, um, the buffer would have to be canvas drawing buffer. No, it's not this. How would I do that? I'd have to take an off-screen canvas and then write it and then dump it in every time. Or take an image or something. That's technically a buffer, right? And a pre-existing image, that's technically a buffer of a pre-existing image, and just dump it in every time. I suppose. I don't think that would work either. I don't think you're testing for GPU writes then either, Fuzz. Even if I did that, I know it. Yeah, single threaded writes and reads. Yeah, it's just, why is the CPU doing it? As far as I know, Canvas draws only when the browser requests a new frame. I'm not sure if the same kind of thing applies to your dot fill. Oh, man. It shouldn't. It shouldn't. Because the frame, it's on demand. I'm not asking for a frame. I'm doing an on-demand thing. So it actually should be fine. That's why you get the canvas output to begin with, because on demand, when I ask it to draw, it draws. Old school GTX program. Yeah, we don't really have, there isn't really a true sense of a buffer in the browser. Not really. And that wouldn't test it wouldn't test it properly on the browser, I don't think, Fuzz, because all that means is that you're skipping the GPU rendering process and you're just talking about how much data you can pump into in into the canvas. Well, no. Damn it. You think a byte buffer would work? I'd have to generate a byte buffer of random data. You've been doing programming graphics since 83, 6502 assembly on the Commodore 64. Damn, Fuzz. That's awesome. I mean, I could generate a bunch of random bytes. How about like, well, I mean, we had it, where was it? I think it was here where they were kind of doing this, which is a uint32 array buffer, right? So we could do that. Right, I could do the exact same thing, take a uint32 array buffer and pop it in there and just put random stuff in there. I don't know. I don't know if that's going to do a proper test, but we'll try it out. Let me just see what somebody else has done, just so that I can save myself some time here. We have an array. Oh, no, that's not going to work, is it? Where's the array buffer, image data buffer? You know what? Why don't I just go over here and just have a look at what an array buffer is? Resizable, slice, byte length, transfer, value of. Can I do... Okay, and then I could do uint32 array, I suppose, and then put in like that. I don't know. I don't even think I need to do that. I could just do a uint. I could just do a uint8 array. That's probably simpler, and just fill in a huge chunk of uint8, because uint8 would be 256 times the 3 pixels or 3 RGB per pixel plus the alpha. So you could do 4 uint8 times 1,000 times 1,000 and just randomly fill it all in and then pump it into Canvas, and it would be, we could do something like, where is it? We could do like what this guy did, right? And just do that. I could try that. The Amiga had dedicated hardware for blitting sprite data to the screen buffer. Same idea here. You draw into a buffer you control the concurrency on, then draw all of it onto the canvas all at once. Okay. Let's see what happens if we do that. Let's just start with something simple. So we're going to go we're going to go, I heard a noise. I heard a noise. Fuzz, thanks for the follow. Appreciate it. Let's just call it buff, okay? And it's going to be a new uint 8 array. And we're going to go y is less than, it's going to be height. And then x is going to be less than width. Okay, and then in the buff, which will be y times width plus x, we're going to put some random number between 0 and like 255. And we need 1. Yeah, that's fine. Okay, hang on. This'll work. I'm pretty sure this'll work. Let's take it one step at a time. I'm trying to think ahead too much. Okay, that's fine. And then how do I put in canvas read array buffer, or like put image data maybe? Sure. How to write an array buffer to a canvas? Yeah. Yeah, so we can do this. Array buffer. Oh, this is it right here. This is what I want. Okay, that's great. And then how do I put the image data? Boom, just like that. Okay, sweet. Sweet. Okay, so we have okay, here's what we're going to do. We're just going to copy this. So we're going to go array buffer is a new array buffer. Nope. I said array buffer. It is important you do that. And it's going to be the width times height times 4. That makes sense. So width times height times 4, because we're going to have our GBA. Then we're going to go our pixels is going to be, well, we can just use a new uint8 array. We could go with clamped. I don't think it matters, though. I think the engine figures out whether or not it's clamped. It's fine for now. Then we're going to do exactly what I did here. And then our I is going to be y times width plus x. And the reason I suppose why it goes times 4 is so that you can, right, okay, I see what it's doing. And then you just go like this. This is going to be 1, and this is going to be plus 2, plus 3, RGB, plus 4. Off by 1. Off by 1, Spiro. Off by 1. Okay, there's our buffer. We want to take this. We want to change it to pixels, like that. And then we're going to go down here, and we're going to create a new image data with all that, and we're going to put it right in there. So at the end of this, we go, whatever our context is, no, wait, sorry, our image data is going to be new image data. And we're going to go pixels, width, height, like that. And then we're going to go put image data. We start at 0 and end 0. Okay. Basic double buffer. You need to account for all the color channels. Yeah. Shipping the pointer to the array buff at 1 should be way faster than sending calls from JS iteratively. 255, not 1 for alpha. Yeah, alpha is number 3 here. So I think we got that, Chronix. Thanks, Abe. I do kick code's ass. That's right. I don't let nobody cuck my code. All right. Okay. So if that works, then we're going to see a spread of like weird pixel stuff, right? It's going to look strange, right? Alpha ranges from 0 to 255? Does it really? I thought it was a floating point. No, you're right. It does. Yeah. I thought it was floating point from 0 to 1. But no, you're right. So you know what? Let's just do 255 then. I want to make a special note of that. They're either uint dates or floats, not mixed. Got it. Okay. 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 So it's got to go up to 255. So we're just going to set 255 on that. All right. Shall we try this? Should we try this? Are we ready, boys? Are we ready? How many draws am I doing? Let me take it down a notch. Let's just do one. Let me just take it down a notch. I just don't want to like run this to the ground with a bad, run, right? Exactly. It's not, the provided value is not of type image data settings. Okay, what did I do wrong? What did I do wrong? Let's go image data spec. Image data. It needs to be a uint8 clamped array. Yep. It needs to be, yep, cronks. Yep, it's got to be clamped. All right. Let's try this. There we go. Okay. Now, what's interesting is that the CPU still beats the GPU at least some of the time. Maybe even half the time, based on what I'm seeing. Although, I don't know. Okay, let's crank something up here. Let's try this. 100 times, but one random injection per run. Let's see what happens then. That's going to take a hot second. Okay, so CPU 24, GPU 26. CPU 26, GPU 29. See? It didn't change. It's still beating it. Well, GPU beat it that time. Yeah, Sky. This does not feel right. Something about this is weird. How on earth is a GPU taking... And you see, the other thing that feels wrong to me is how much longer sometimes the GPU takes than the CPU. Like, you don't normally see the CPU take that much longer. Maybe by 2 to 3 seconds. But here we're talking like, what, 6 seconds? Okay. Okay. Yeah. How? Yeah. Something ain't right. And the only thing I can chalk it up to, we have context 2D. We don't have 3D context. We have will read frequently true. Let me see how much the reads are. Test reads. Let's see what happens with the reads. The read should always be CPU wins every time. Flutter draws to a canvas. That might be a good place to look to understand. But it's, yeah, CPU outperforms GPU but on reads by like magnitudes of order. So I'll do it one more time. I don't think that's the problem. And Flutter is a little bit different because it comes with its own set of abstractions in order to do writes, because it has to be cross-compatible with a bunch of different things. So what you're importing in with Flutter is Yeah, it's not seconds. It's milliseconds. Sorry, Sky. My bad. It's milliseconds. It's not even. Is it even milliseconds? Yes, it's milliseconds. That's performance.now is milliseconds. I apologize, Sky. The problem with Flutter is that you're importing a bunch of stuff it tries to solve, and so when it's writing to the canvas, um, you don't know what else is impacting its ability to do that. And it's the same. I think it's the same problem here, but just for a different reason. The problem that I'm seeing here is that the browser and the JavaScript engine are probably doing optimizations that we're not seeing under the hood. As a matter of fact, application, that's performance. It's not what I want. I don't think I want, no, I guess it's not application. Is it memory? No, maybe it is, maybe it is, it's performance. Okay. But can I run anything while I'm doing that? No, I can't. Yeah, I wish I could get the performance while it's running, but I'm not sure that I can, honestly. Record and reload. Let's see. No. Um, man, I wish there was a better way to take like the data out while you're running it and profile it so you could see what's actually being used. Because I think I'm suffering from optimizations on the end the browser. You mean the engine under Flutter? Yeah, I don't think it would matter in this case. I don't think it would matter because I think what you'd end up having is the engine the engine doing things in the same way that like look one way or another you're going to render to a browser, right? So whether it's a double buffer, whether it's a single buffer, whether it's a repeated buffer per animation frame, whether it's once with minor adjustments, you're still going to end up with whatever's going on here because you're ending up at the browser. So I don't think ultimately it matters. In fact, my way is probably far more closer to the metal than Flutter is because again, I'm basing it purely on what I get out of the browser, and that's really what I care about. I don't really much care about what Flutter does because I'm never going to use Flutter, right? And I'm never going to approach things the way Flutter approaches it because that's not what I want to do. I want to do it with the least minimal overhead as possible. And I think the more, yeah, baby's like, yeah, this is interesting. I agree. For a lot of people don't find it interesting, but I sure as hell do because something's going on in here that the CPU, you know what? Let me change one. Let me try something. What if I did this? Let's go like let's go 300. What if we make this a lot smaller? Like the actual width of like of the, the image. Yeah, how is the CPU faster? Yeah. 2.1, 2.3. How? And this is another thing. How on earth did they take the exact same amount of time? There's hot branching. There has to be. The browser and or the JavaScript engine must be caching something. And it makes the GPU and the CPU draw it equally as fast. They have to be caching something. They have to be optimizing for something. Yeah, how is it? How? Nah. Nah. Nah, man. Okay. Um, why is CPU drawing faster to canvas than GPU? But I want canvas. Um, could this be me? Could you imagine if it's just I have a bad like laptop? Like and my CPU is faster than my GPU? I mean, it's a what is this thing? There's zero shot. There's no shot that's what it is. What I have. I've got an AMD Ryzen 6900 HX processor, and my video card. Where's my video card? Where are you? RTX 3080. With, I don't remember how much RAM it's got. 8, 16, I don't know, something like that. Not like a heck of a lot. But there's no way. Maybe it's using SIMD. I suppose it could be. I wouldn't know. I suppose it could be doing that under the hood on JavaScript or on the browser, or just the delay for CPU GPU transfers making GPU slow. Or maybe, you know what else I could try? 3080 is baller. 3080 is baller. I agree. You know what I could do? Here, I've got another browser. Let's just try another browser. This is my Enlightened Programming website, by the way. I'll be putting this stuff up on here. All this information I go through. I have a bunch of like daily tech news stuff that I go through. You can go on enlightenedprogramming.com. If you tip, you know, or if you've ever subbed on Twitch or something or financially supported, you get access to it, and you can do things like search for. This is my admin panel. The typical panel looks different live, but you can search for things like what's the one that I'm thinking of right now? I can't remember. It's floating. Yeah, floating point accumulation, things like that. Like I go over all this stuff. In any case, okay, let's do this. Okay, so here we are. We're on, this is Mercury browser, right? And then if I try it on here, test draws, what happens? CPU took 42, GPU took 39. Okay, let's try it again. CPU took 49, GPU took 43. Now we're talking. So it's Chrome. Should I try Firefox? Oh, CPU took 37, GPU took 38. Oh, hang on. Hang on. Okay, GPU 1. No, CPU 1. Oh boy, something's up. Oh boy. GPU 1. CPU must be doing caching. That's what I think. It's hot pathing some kind of. They were the same. Yeah, CPU's getting a win out of hot pathing the drawing. It's equally the same. Equally the same. Yeah, CPU's doing caching. Hard. CPU took longer. Okay, so GPU 1. I'll do it one or two more times. You think I should try Brave Creed? All right. CPU 1. Yeah, no, man. Nah, Baby Yoda. Nah. 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 There's optimizations going on. Let me try Brave. Do I have Brave already? I don't. Download Brave browser. We'll do the setup, blah, 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 blah. Is Brave WebKit, though? Or, like... Yeah, it uses WebKit. Is Brave Chromium? Like, does it use Chromium? Does it use CEF or something? You know what? It doesn't matter. I have it installed. It's too late now. Let's go back to... I want to get the URL here. Here's Brave. We're going to try out Brave just to see. Whoops. Here. Yeah, you can tell. So it's going to be the same thing, man. It's going to be the same thing. Yeah, CPU 1. CPU lost. CPU 1. Same. CPU 1 by a lot. CPU 1. CPU 1. Bro, CPU 1. CPU lost, CPU lost by a lot that time. CPU won, CPU won, CPU won, CPU won, CPU won, CPU lost barely, CPU won. Bro, yeah, man. Do just CPU then GPU. But that's what I'm doing. That's what I'm doing. I'm doing CPU and then I do GPU. I run through all the iterations on the CPU and then I run through all the iterations on the GPU. Sky or psych. I keep thinking it's Sky. Yeah, man. What is the test exactly though? Because some things would be slower on GPU because it probably needs to render geometry. The test is how fast can I blast pixels onto the canvas? Can you clear the cache between them? I could do a clear rect. I can't clear the cache, not on the GPU. I don't get to control, or sorry, not on the CPU. I don't get to control the CPU cache. CPU cache is controlled by hot pathing and other stuff that it finds or determines is of import in regards to running at performance. I don't really get to choose that. The only way I could clear the cache is if I fed it a bunch of other stuff that I hope ended up in cache. Where's my clear rect? It would be here. So I could take this and at the end, I could do a clear rect on the whole thing. So we could just try this. So I'm going to refresh. What's wrong? Missing what? Oh, okay. Okay, so what this will do is it'll do the exact same test. CPU will blit the canvases, GPU will blit the canvases with the buffered up, pre-existing, ready to go image data. And then we'll see how quickly the CPU and the GPU do if we clear the canvas every time. I don't think it's going to make a difference, honestly. CPU won. CPU won. CPU lost by quite a bit. CPU won. CPU won. CPU lost by a little bit. CPU lost by a little bit. CPU lost by a little bit. CPU won. CPU won. CPU lost by a decent amount. CPU lost by a lot there. CPU won. CPU's the same. CPU lost by an entire millisecond. CPU lost. CPU won. CPU won. CPU lost by a lot. CPU won. CPU won. CPU won. CPU lost. CPU lost a little bit. CPU lost. CPU did the same. Damn. Won by a lot. Won. 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 Lost by a little bit. Man, this is so weird. This is so strange. And you can tell that the clear rect work if you go like this. I guess you can't see it, it's too fast. But if we take this out and just run it again, yeah. And now what I'm going to try and do is, what if I did like 1920 by 1080? Yeah, it's a fill rect. It's like a fill rect. Yeah, it is essentially a fill rect, but you just fill the entire rect. Yeah, this is going to be huge. It's going to take a second to run. 1920 by 1080. CPU lost. CPU won. Holy crap. Damn. They are so, yeah, baby. They're so neck and neck. Nah, man. How does a CPU win by this much of a margin? I mean, it's a few milliseconds, but still. Yeah. Okay. All right. Certain operations can force a browser to switch from GPU to CPU, which can have significant performance implications. One of the most common triggers for this is the frequent use of get image data. This function allows for pixel level manipulation in the CPU, but it requires the browser to transfer texture data from the GPU's memory to the system, a process known as GPU readback, which is notoriously slow. Yeah, that's not what we're doing here, though. Yeah, right. Yeah, I know. Yeah, I know, Fuzz. We're not reading, though, right? We're writing. It's the writing that's the problem. We already knew. We've proven it beyond a shadow of a doubt that reading from the GPU, that's get image data. Reading from the canvas, I mean, is stupid slow on the GPU, and that's already known, and that's fine. We're okay with that. This is about reading in or like writing into the canvas, which is essentially should be a GPU. It should be a GPU operation when GPU is enabled. But when you disable GPU, when you say I don't want the GPU to write to the canvas for drawing pixels, and the CPU takes over, the CPU holds its own. Maybe the random number generator is what we're measuring. Yeah, it could be, baby. But I don't think so, right? Because okay, let's take this out. Let's put the start right here. So what we're going to do is we're going to literally start right at the put. This is the only operation that we're going to be checking. That's it. Let's just do this. Uh huh. Uh huh. That's quite a jump. That's quite a jump. Uh huh. Wait. Wait. Have we turned? Have we turned the tide? The fact that they're getting 1-1 is bonkers. I think we might have turned the tide. Oh damn. Maybe Baby was right. Creed and Baby were right. We were measuring the random number generator. Fuzz, I think we got it, man. But thanks for sending that in. I think we got it, boys. What in the chat, Gupta, is this heresy? Shut up, Erica. Yeah, we did it, boys. We did it. Good job. Creed and Baby, you guys nailed it. You watched too much Casey Muratori. Me too, man. Yeah, we did it, boys. GPU, look at that. And GPU is consistently now drawing at that level, whereas the CPU is going all over the place. So that's exactly it. That's exactly what we wanted, is the put image data. Yep, GPU wins. GPU's winning all of them. So yes, the first one was a red herring. we were testing the CPU's random number generator, not the drawing. There we go. Confirmed. Sweet. Boys, I thank you. This is why I like to do this live, and why I stopped when I was trying to figure this out, because it's way funner and way more interesting, and you learn way more when you pool the knowledge together between chat. I can't count how many times I've had chat and worked with them to come up with a test like this to build this game. Chat has helped a lot with this game. That's why I'm able to do CSS 3D, because chat helped me with that. I can do CSS 3D, boys. Vanilla CSS 3D, by the way. There's no third-party libraries. This is vanilla CSS 3D using just DOM, right? And you guys helped me with that. WebAssembly with C, you guys helped me with that. And now coming up with this test, you guys helped me with that. So it is now confirmed. We're good now. We've now confirmed. Shut up. I shouldn't have done the last test. Look at that. I shouldn't have. I went for the sun. I went too close to the sun. Arakar sent a message. I went too close to the sun. This is how you know they belong to the hoodie of the studio. You still think the GPU is being gimped. I agree. It has to be, right? I'll send you an FBX. Can you import it? I mean, I actually could, Arakar. I believe I can. But you can see on subsequent tests, you know, I wonder if it's a timing thing. When you test consistently, so let me test consistently, and then what I'll do is I'll run one or two more, right? So GPU is winning now, hands down, it's winning. Easy win. Look at that. Nice easy win for the GPU. One more. Okay? Okay. Now I'm going to walk away from this and I'm going to give it a second. All right? I'm going to give it a second, and then what we're going to do is, Arakar, if you want to Discord me the FBX, I'll try and figure out a way to import it. I'll try. Micro benchmarking is easy to do, hard to do it correctly. Yeah. Canvas mark. I think I have that one pulled up, don't I? No. No, I don't. Let's pull this one up for fun. We'll step away. This will be a good test. Here we go. 2013 HTML5 Canvas 2D rendering. Look at this. Oh, yeah, look at this. Oh, look at this. Bros. Buzz, this is fantastic. Look at this. 2013, man. I'll send it without textures just to test. Sounds good, Arakar. Oh, look. 2013. This is, okay, this is exactly what I mean. Thanks for sending this over, Fuzz. This is what I mean by the entire tech industry has completely lost their minds. Because this kind of stuff runs like purrs like a kitten in today's hardware. Think what you can do on the browser these days. And think what you could have done with this in 2013 with these benchmarks. And instead what we do is we abstract and obfuscate and add layers of things on top of stuff. We make things worse. We don't make things better. This is insane. Look at this. No need for WebGL. Yeah. What do you need it for? Mostly Chinese, but the diagrams are in English. Let me pull this one up too. Yeah, this is, look at this. What do you need WebGL for? This is really, really cool. Okay, I'm gonna keep this in the background, okay? And I'm gonna pull this up. We'll look at this later. Thanks, Fuzz. You can see they have some like canvas rendering stuff. I'm sure you can do a translate here. Translate to English, translate the full page. Yeah. You can see web page rendering with Canvas 2D with a context. You can kind of see how it works. I wonder when this was authored. I wonder how up to date. 2022, so even recently. Sweet. Okay, I'm going to look at this. I'll look at this later because this is going to give me some idea on how it actually gets rendered. Low latency mode is desynchronized. Okay. Nice. Okay. Okay, I'll look at this in a bit. Empty code, Yo Spear, I finished the homepage of my website with pure CSS and JS. Let's go, man. It has animations and all that, and I still didn't see a need to learn a framework. Exactly, Empty. Exactly. Except for when I needed selector, it was kind of hard, but I'm a noob. Selector is pretty easy. All you have to do is, here, I'll show you. It's pretty straightforward. So if I want to pick any element on the page, I'll just do this real quick, and then I'm going to pull up, I just want to try out Emmett's thing here. Let me, hang on. What's the dot grid item? So selector is this. Watch. Document, query selector. Query selector will pick one element out of all possible elements. You'll note that I have a thing called grid item, and grid item here has a class, which is multiple times. In semantic HTML, you're supposed to only have one ID. So if you put an ID attribute on these elements, it should only exist once on the page. If you have a class, it can exist many, many times. So if I want to target the class, it's only going to give me the very first time that it finds that class item, right? If I want to get all instances of that class, now it gives me all 144. Classes are prefixed by dots and IDs are prefixed by hashes. So if you look at, let me see if I can find something with an ID somewhere here. ID map info, let's do that. So you can take that and you can go map info. And there you go. It's the ID that should only exist one time on this page ever. If I do query selector all, it just puts it into an array, and the array length is 1 because it only ever exists once. Now what you can do with query selector is you can actually chain these. So if you want to find all grid items inside of map info, say because you have grid items that exist somewhere else as well, you can do this. So map info space dot grid item. And now you can filter it by top down or bottom up if that's what you want to do. So that's what the query selector does for you. Okay, so there you go. It's not that hard. It really isn't as hard as you think it is. Just use your IDs correctly, use your classes correctly, and know the difference between query selector and query selector all. You're off to the races, man. It's super easy. Okay, now let me see what our car sent over here. It should be in T-pose. Okay. It's a potentially dangerous download. I trust you. I trust not to be virused. Okay, here's an FBX. So how would I load FBX into Canvas? Thanks, AR. Yeah, man. Yes, I use query selector and class names a lot, but I was talking about the select element and how you can customize it. There are guides on that online too. Oh, the select element. Right. So the select element is particularly weird. And the reason why it's weird is because it has browser specific input options. So the HTML select element, so you can see there's like an option, right? And whatnot. So certain browsers will treat it differently because what they'll do is they'll try and make the select element look like what's appropriate to your operating system. And so as a result of that, you're going to have to kind of just accept certain facts. You might not get it looking correctly across all the different platforms unless you tackle like Safari on iOS and Chrome on iOS versus Safari on Windows versus Chrome on Windows. So you're going to have to play around with those kinds of things. And WebKit in particular has its own kinds of stylings where you have to do a weird prefix of like, let me see here, input select. No, yeah, input select styling, where you do WebKit prefixing. So there's the appearance, there's these double semicolons here for picker. You can do the options. You can customize the options a little bit, right? So you're gonna have to just deal with that. It's gonna be annoying, but essentially what you can look, I'll show you. In order for browsers to keep backwards compatibility, they have had to do one of two things. One thing they've had to do is a double slash. You're going to see this sometimes. So sometimes when you look at a style, let's go look at a style. Okay, here. If I do double slash or single slash, I mean, not double. And it's not slash either. It's dash. Man, I'm tired. Single dash like this. You see these WebKit ones? See these WebKit ones? These work on like Brave, Chrome. I think Firefox, I think Edge now since it's doing Chrome stuff. So sometimes you're going to see things like select elements, checkboxes, progress bars, dialogues, other native HTML elements that use these prefixes of one dash WebKit. In other cases, you're going to have to do something like, let me see here. You're going to have to do something like if you're putting in a style, right? You're going to have to do something like that, right? And then something here. So it's going to be like select something. And it's going to pick a particular attribute of the select or whatever it is. This gets really weird. I have to admit, Empty, it gets really weird because you have to remember all these quirks. But fundamentally, the only thing that you really have to do is just look it up. Just go read the specs. And you don't have to remember what it is. Once you've kind of understood why these things exist, you can pretty much forget about them. And as long as you know how to go read a spec, like go on MDN or go on W3C and read a spec, you're going to always be able to find what you're looking for and how to style it. But you just have to get through this initial period where you're trying to like figure that out. FBX is proprietary? Okay. If you want OBJ or another file type, let me know. For 3D models, you need to have a lot of code, though obviously you can't use CSS. Either your own 3D render in JS or WebGL. It would have to be, yeah, I guess I don't know if FBX will work on the canvas, will it? Nope. It won't. And you know what I'm realizing right now, Arakar, Emmett, you know what I'm realizing? I'm not doing 3D right now. I'm doing 2D. So it actually doesn't matter. Unfortunately, it's not relevant to my current test. I don't even have it set up for 3D. I'm just realizing that now. MT says, yeah, that's pretty much the only thing I faced. I was like, maybe it makes sense to just have pre-made or better select, which is a small need compared to the size of the frameworks. But again, you can customize it with CSS. It's just harder, right? Yeah, Fonts Berkeley Mono, man. Yeah, that's right. Bunny Mark. Yeah, I don't think it matters for this because I'm doing 2D, not 3D. So send me an OBJ of it anyways, but I'm going to have to set up a 3D thing. It won't work in 2D. I could try software blitting a 3D on CPU on a 2D canvas. I could try that. I could rasterize it maybe or something like that, but yeah, I'm not there yet. I actually am realizing that I'm not there yet. Here's the bunny. Look at this. Look at this. 63 FPS. Look at this. Look. Look at that. All those bunnies. 3,000 plus bunnies. Yeah. That's what your machine is capable of doing. But you know what we get instead? Instead of that, you know what we get? The creme de la creme of frameworks. Do inspect for the source? Yeah, sure. Hang on. It's just a canvas. A bunch of simple objects, and then you just drop them in, and you just do a XY coordinate with an interval on speed. That's it. Position absolute. Yeah. Yeah. So instead, we get people like Theo and others who are so brain rotted that they give you this. Behold the creme de la creme of what is considered the very tippity top of websites today. We just did the bunny thing. We did the other one with like the asteroids and the 3D and all that. We've got this thing with CSS 3D, right? And it runs quite well, and we're not done optimizing it yet, right? And then we have this. It's basically just like write it. Yeah, just write it. Yeah. Check this out. Creme de la creme. This is peak peak web development here for you. This is the kind of crap they want for you. I can sit here and do this all night, and you can watch my resources go up. You can watch I'm not even clicking them. I'm simply just hovering over them. That's all I'm doing. I'm just hovering over, hovering over, hovering over, hovering over. That's it. This is peak web development right here. And in the meantime, we can put 3,000 plus bunnies on screen. We can do the asteroids with like a million, different sprites. We can do insanely cool video games. We haven't even scratched the surface. Even this GPU stuff, which I'm glad we sorted out, by the way. Thanks again with chat. This was fun. I'm glad we figured this out. We got this. Now I do have to go back to this because remember what I said? What happens if I leave it? Will the CPU win after given enough time? We've given it a lot of time, right? Will the CPU win? Let's see. But this is what I'm talking about. The tech industry has completely lost it. And influencers and streamers and other people, yeah, the CPU wins, right? Now, if I keep doing it, the GPU wins. And now the GPU is going to stay winning. Yeah. Well, the CPU actually won that one last time. But yeah, there you go. So there's something about like the first initial draw where the CPU wins for some reason or another. Who knows why? But subsequent draws, the GPU wins. And that's important to me in this game when I'm doing immediate mode, where I'm dropping the entire set of HTML and I'm re-rendering it all over again. Right? So ultimately for my game, we've now confirmed this is what I want to do. I want to turn on CPU only for reads and GPU for writes. So I can turn on the GPU for writes, and then I can create. Anyways, I'll figure that part out. I'll have to figure this part out. Do I create a new context? No, I can't. I could do CPU only. I could extract the data. I'll figure this out. I'll figure something out. But essentially that I now have a way to confirm CPU wins on cold start every time. It probably does. It seems like it does. Bunch of good info. Oh, I've read this one actually. Yeah. Yeah, this one's good. I might need to read this again. No, I actually remember this. This is one of the reasons why I did some of the stuff earlier. Yeah, this one's good though. Thanks for sending that over. Gravity demos? Oh, we got to try this. Hey Mosta, how's it going, man? This is using a lib though. I used P5 for what it was ages ago. You should also consider layering canvas, or you're only drawing what you need. Yeah, Twitch recommendations good. Thanks, Mosta. My own Twitch recommendations. Well, we're having fun over here, that's for damn sure. So let's go over here. I only do a 2D developer, yeah. Oh, right. This would be using the P5 library. Yeah, but still. Yeah. Okay. All right. Thanks for popping in, Masta. Yeah, I appreciate it, man. So what I'm going to do, so here's the deal. Now that we've confirmed that the CPU can read way faster than the GPU, and that the GPU can draw way faster than the CPU, except for on cold start, apparently. Look at that. And now it'll start winning. Yeah. Okay, we've confirmed it now. We just had to not track the random number generation. Why should everyone be booing me, Arakar? Why? Shut up. I only do 2D, okay? Okay, so now that we've confirmed that, essentially what I want to end up doing is I want to take the layers that I'm doing here in this game, and I want to write it to one canvas. And so what I'll do is I'll take one canvas and I will layer. So, okay, so here's what we're going to do. This is what I'm thinking. Um, because there doesn't seem to be much difference between the CPU and the GPU in terms of rendering, but there is, well, it's going to be a little bit slower. Crap. I have to think about this. But essentially, this was my ideal goal. My ideal scenario was that I would layer the first background layer first. That would be the ocean, right? And so I'd take one canvas and um I'd put the ocean first. Then over top of that, when appropriate, I would take the same canvas and I would do the next layer over top. Because if there's a portion of this that is see-through to the ocean, which in some cases in the edges there is, I want that to show up in the background, right? So then I take the same layer and I layer the ground, the next layer over it. Then if it's the NPC, then I layer that as a like on top of that. And then if it's a building and so on, let me just go up here with like you know, all the different things here. Then I would take like the rock here and I do it on top of that. And I just stack them all and layer them all. And then that way, instead of doing what I'm doing right now, which is if I pause it and I go down to all the individual HTML elements, which run surprisingly fast, if I take each grid coordinate and instead of having one element per layer, I just have one element for all layers with a background image that is canvas generated with all the layers for that particular XY coordinate stacked on top of each other, punched through and shown as a background image, then I can reduce the number of elements that I have on the page. Because I think right now it's like 12 by 12. So that's what, 144 times 6 layers or something like that. So we're talking at least a few thousand elements here. And when you start talking about that number of elements, the browser starts to choke up just a little bit, right? So we have to consider that, and we want to reduce the number of elements, and we want to try and leverage the fact that we have a CPU blitter, essentially, that we can use. You were bamboozled. You know what, Emmett? I can do 3D. All right. I can do 3D, but I'm not there yet. Look, but it's because the 3D stuff isn't what you think it is. Hang on, I gotta go 3D. Look at this, Emmett. Look at this. Look at my 3D. All right, I can do 3D. It's just not what you think it is. This one's a little glitchy, probably because I played around with it, and probably because there's a bunch of elements too. And when I go back to 3D, I'm going to have to consider that removing elements is actually going to make 3D harder. Because if you think about it, I want the NPC to be a different element in 3D mode. I can't take one element and then, you know, prop it up, right? So I'm going to have to consider how I deal with CSS 3D. For CSS 3D, I want individual elements that pop up out of the background. So I'm going to be killing 3D initially. And then I'm going to have to like generate elements when I turn on 3D mode so that I can pop them out and extrude them in the X, Y, Z coordinates. So it's going to be a little bit of a, I don't know. Masta, thank you, man. Thanks for the follow. I appreciate it. I'm going to have to figure that out. Right now, I get the benefit of having individual elements per layer per grid, which means then I can choose how I put them in 3D space with CSS. But if I remove the elements and I just do canvas layering, you know what I could do with canvas stuff? Because let's say I take my ideal position, I can do not composite them yourself. Let the browser do it. This is what the last link I sent is about. I suppose I could let, yeah, okay. You think I should just let them compose themselves? Just put two canvases on top of each other? The first, hang on, let me pull this up. This would be cool for an MMORPG. It would be 3D. The reason I started watching is because of this demonstration. It's a good one. There should be an option to add a camera for 2D, 3D so you can orient the art to the camera. Yes, there is. That's what I have. That's what I have here, right? On help. I can turn 3D on and off. And literally while you're playing the game, you can just switch to 3D mode. Right? So I have that. The only issue with this is the buildings. I mean, yeah. Well, I figured out the buildings actually. I'll read this in a second. The buildings are not as bad as you think. Gotta refresh this. Here's why. What you can do with the buildings is you can take the entirety of the building and you can take the backgrounds of the buildings and then you can prop them up the same way that the characters prop up. Right? I mean, the building laying flat is kind of cool. It's a little weird though, right? But you just take the entirety of the building and you prop them up like the NPC. So it's not so bad. And then it's got height, right? Because the sense of height in 2D isn't the same as 3D. Oh, you're saying add a camera. You're asking for a lot, Emmett. I actually think that might not work out as well as I hope it will in this browser-based ecosystem. I think there are some limitations, and I think camera is one of them. However, I want to. Just like I wanted to have CSS 3D, and I did it. And I wanted to have no third-party libraries, and I did it. And I wanted to have WebAssembly with no standard library and no glue like Emscripten or anything like that, and pure numbers in and out, and I did it. And just like I wanted to have the WebAssembly run the game state so that I could run it on a proper 3D engine like Travis Roman's Kohi engine, and I did it. Okay, so I accept your challenge, sir. Okay, I accept your challenge. Okay, this compositing thing. Instead of redrawing the background each time, just put two canvases on top of each other. First, draw the background image once on the bottom canvas. Then use the top canvas to draw all your changing drawings. Is this what you mean, Fuzz? Was this your compositing thing you mean? Yeah? I don't think this will work, though. Because my background image constantly changes as well. Like the animation here, where the heck did it go? Can we see the responses to him? Is it not working? Is Restream not working? Oh, it should be working. Oh, you want to see the responses to him? Sorry. Here you go. Here you go. Sorry, my bad. I misunderstood you, man. Here. I'll try and fit it on screen if I can. This looks like a clever idea, but unfortunately my front and back canvases have to rotate. And also, ultimately, it will only be part of the background image being drawn, depending on whether the player's sprite is on the screen. Correct. That's my problem, too. The grass and water do change. Yeah, they animate. Yeah, so every frame, they animate. Like, the water will sway, and right now, the grass doesn't. But the grass will, like, it'll make movements and stuff. Fair enough. Okay. Yeah. Yeah, I'll show you the ocean in a second. Oh, it's okay. It's okay, man. Let me show you the ocean because that one does move. So here, you can see it move, right? The grass doesn't move, but we're going to make it move. But you can see the ocean move. There's also this in the original game, because this is a recreation of a Super Nintendo game, my favorite game of all time. That's why I'm recreating it here on the browser. But wait, if I set sail, you can see the ocean moves, and then my ships auto move along with it, right? The graphics are terrible. Graphics are terrible. Arakar is going to laugh so hard when he sees this. But yeah, there you go. And then for battle, I believe when I battle another ship, they also move. Yeah, the ocean also moves. And then the movements for the battle, it just moves grid by grid. That's all. So some of this is simple, but some of it is not. And we're enhancing because I'm getting help from people who are giving me nice pixel artwork with animations, and attacks are going to be animated. The ocean stays animated. Grass is going to be animated. We're going to have clouds. There's an entire storyline that's going to, make things really cool. I'm going to plug an element of this into all the NeoCities websites that are being built here with some chat. We're going to integrate Twitch chat and the other chats on YouTube and everything. You're going to be able to type in commands and play against each other on here. You're going to be able to play multiplayer like on your own machines. You're going to be able to do um, an entire campaign mode, a single player. So if I'm gonna do that, then I'm gonna need some animations, and unfortunately, the compositing is gonna have to be up to me. And I think that's what I'm looking at here is when I composite it, I'm gonna have to take one canvas and I'm gonna have to draw each layer over top of each other, and that will be the see-through over top. And the nice thing about that is when I go into 3D mode, if it's one element per grid with all layers smacked into one image, I can extract that in 3D mode. And I can say, add in another element for the NPC, like what I have here, or your moving character or whatever. This now becomes a second element, and only draw on a canvas that is dedicated to drawing this element. Same with the house, right? What kind of like what Baby and I were talking about. You take the house and you prop it. You prop it up like the NPCs are, right? And that becomes its own element. And then you just draw that on a separate canvas. And then when you go back to 2D mode, you just flatten everything again and remove the extra 3D elements and their positions. So then the only question that's left is, do I use No, you know what? There's a principle to this project. That's right. I'm following a principle in this project, and I am purposefully handcuffing myself in order to make a point. And that point is that the tech industry frickin' sucks. And we're building shit all the time. So I've handcuffed myself with everything I do on this thing, going down to nitty-gritty details. Are structs better than flat arrays, for example? We opened up Godbolt. We literally looked at the assembly. I mean, we agonize over everything. So here's the deal. We've proven that the GPU version does render faster than the CPU version, but I'm not trying to look for the crutches, right? I started the entire stream this way. We're going to do CPU-based rendering. So it's all going to be CPU-based rendering. We're going to draw everything we need to draw. And we're going to try and be clever. Things that are that we can hold consistently in memory on first load, we'll draw that on first load. And then we'll try and draw as little as we have to on the CPU on a canvas on every frame, because we're dumping all the frame, like we're dumping all the data and rewriting it. It's immediate mode. So we're just going to see how far we can push the CPU. How clever can we be with it? And how far can we push the rendering? And if we try and load up to the front, like if we load it to the front, to the initial load, as much CPU rendered stuff as we can on a canvas, then the reading of that will be, because we've proven that now, right? So if we have a 2D CPU-based canvas and we want to extract the image data and put it in as a background to a single element, it's going to reduce the number of elements we have. It's going to reduce the number of times we have to re-render or re-import, images or whatever. And hopefully it means that we'll get, overall, it will become a net positive. That's my goal, because we're going to do this dumb caveman way and see how far dumb caveman way gets us. Okay, we're going to find out. Thanks, Spartacus 2027 for the follow a few minutes ago. What's up, Pickled? How you doing? Good to see you. We'll see what happens. We'll see what happens. But that's the plan. I wanted to run this live on stream with you guys and work this out so that there's a record of it, because this project is basically a big slap in the face. To the tech industry, if a high school dropout like myself can do it, because I had to run away from home because it wasn't good for me. I had to save my own life and then be homeless for a while and live in my car and sleep on park benches when I didn't have a car. That sucked. That really sucked. And so I self-taught myself everything. So if I can do this crap, then certainly the tech industry can do a lot better. So now that I have this on record, I have a plan. This coming week, I'll spin up another indie game stream. I'm going to be doing a bit of a news one tomorrow. We'll cover some news. We're going to have Delaney from Datastar come in. He's going to talk about some tech drama. That should be fun. We'll do that. And then throughout the week, I'll fit in some more indie game streams, and we'll work on this canvas rendering now. And maybe what I'll do is I'll add some nice things to the mud that I've got running here to this thing. I'll see if I can come up with something instead of this like Dwarf Fortress style map. Maybe, I don't know. I'll try and come up with something. You know what? I need to attack the blacksmith, and I'm probably gonna die. I'm dead. The blacksmith killed me. I'm dead. Anyway, this is a game you can play, by the way. It's on uwnhremake.com, but this game is going to get taken away, and we're going to merge it in with the boat ship chess game that I've got going on here. And that's what all this work is for. I did the mud game to prove a concept, server sent events, SSE, with post requests for individual actions. The one other thing that I want to try is CQRS, or event-based sourcing, so that you can go back and forth. I don't know why this isn't loading, but maybe because of the game. Oh, you just have to type in your username. Got it. And then it loads. Yeah. Yeah, I want to do like event sourcing where you build up a whole bunch of events and it gets you to, a certain point in the game, and so that you can do like replays and stuff. I want to try and play around with that. Um, yeah. 1972 Chevelle. Hey, at least that's something. I built some huge canvas engine in college, which sounds like it had similar limitations. Things that got me is the sawtooth memory spike, just drawing images. These days, looking a lot into WebGL for any game stuff, but I haven't really done a lot for years. If I had to pick something to get me going fast, WebGL for sure. It's just a quick way to get going. That game, if it was an MMORPG, would be so. This game, if it was an MMORPG, would be so good. Yeah, that's what we're gonna do. We had a previous version of this game, baby, a long time ago. It's still up on my lives on YouTube. That was multiplayer. It was here. I'll show you what it was. It was this thing. There were 5 ships, and Twitch could possess one of the ships, any one of the ships. So as long as first come, first serve, you grab one of the ships and you just attack each other with cannons or board like man-to-man attacks. When I got raided, I would spawn a Kraken. I still have a Kraken pixel art somewhere. A Kraken would spawn randomly on the map, equivalent, it had HP equivalent to the number of people in the raid. And then the entire chat would have to go and attack the Kraken because the thing was overpowered, right? We had that running. That was a multiplayer server we had running. That was really cool. And what I'm going to do with this multiplayer server, now that I've got the mud working online, we've proven that it works online the way that we were hoping it would. I'm going to take a bun server, and I'm going to take my C code, which is here. Here, I'm going to take all this C code, the single file header library in C, which is approximately 7,700 lines of code. A lot of it has to be removed though. And I'm going to run this C code inside of Bun, because you can do that with FFI. You can do that with foreign function interfaces. So you can take the C code and you can use it to number crunch your way through a Bun server. And then the Bun server will just provide the server, the SSC, which is just a TCP HTTP connection that just sends stuff to you. It's one directional. And then you'll just send post requests, like form data request, up to a post server. And so your request would be, like a typical form submission, right? I wrote the backend to Coke Studios. If you need any help with backend advice, I did a clean room implementation in Habbo Hotel. Oh, cool. Thanks, man. Yeah, thanks, Fuzz. I will. Yeah, okay. Okay, if I need help, I'll reach out, man. Probably will, honestly. Probably will. 2002-ish. Hey, it's still valuable. What's up, Super Foxer? You see someone exhausted drag themselves towards the stream. Hello there. Are you exhausted? Man, you just missed it. I'm about to end the stream. We just went over CPU versus GPU canvas rendering. We ran like a little micro benchmark just to prove the points out, to improve the game that we have here. This multi-user dungeon game I built that's actually running. We've proven a bunch of concepts, and then we're going to merge this game into all the concepts we've proven out in the multi-user dungeon game, and we're going to make it all one thing. And it's going to have like a single player campaign, multiplayer. Chat's going to be able to play with it, whether no matter what platform you're watching me on. You're going to have commands, all of that stuff. Tired but good. I finally finished my game after spending the whole night adding the final things. Good job, Super Foxer. That's what I want to hear. A server could handle 100 times as many concurrent users as the actual Habbo Hotel. All Java, never again. Never again. Never again. Yeah, that's cool though. Are you familiar with Deltarune? Am I familiar with Deltarune? Am I familiar with Deltarune? Of course I'm familiar with Deltarune. I've never actually played Deltarune, but I've seen people play it, and it looks really, really cool. In my opinion, it looks cool. It's the parallel story to Undertale. It's the jumbling around of the words. Yes, I do go on Rust now. Yeah, I want to play my game. Then it's a bit what my fan game's about. I don't normally play other people's games on here. Normally because I don't have time. I'm sorry, Super Foxer. I don't have time. I don't have time to do it. However, I will play it offline. I just don't play it usually on stream because I usually don't have the time to do it. But if you send it to me, you can just type in !Discord. You can hop on Discord. You can send the game. Myself and probably several others would want to play it and try it out. So yeah, if you want to do that, you can absolutely do that. Okay. Well, I think I have a plan. When you said normally, I thought you were going to say something like that and then say, but today's not a normal day. Nope, sorry. No exception, Super Foxer. We're based around here. Well, I am anyways. Chat kind of sucks, but I'm based. You know what I'm saying? Okay, I'm going to call it. It's late for me. I appreciate it. I appreciate everybody being here. There's a lot of people on the YouTube side. Hey, everybody on YouTube. Way more people on the YouTube side. It's crazy. What the hell are you all doing over there on YouTube? You guys just like bored and watching nerdy stuff? It's 8:30 a.m. here? Yeah, I get it, man. I get it. The hell's going on YouTube? You guys are crazy over there. But thanks for watching. I've got like, I don't know, 20 people or something there. That's insane. That's cool. Thank you. 2:30 a.m. here. Yeah, 11:30 here. So it's getting kind of late. I gotta go. I've got work and family stuff to do. Okay, so here, why don't I do this? If you want to join my Discord, you can join my Discord, and you can chill your game if you want there. Maybe just ask just before you do it, just to be sure. But normally we let people drop links in there. It's okay. Just as long as you ask, it's usually okay. You can also, if you want, if you like what I'm doing here, you can send in a tip on Streamlabs. You can sub on Twitch. You can super chat on YouTube. On the green stuff, you guys know what to do. You're not supposed to say the actual names of that. On X, you can just come and tip. I multi-stream to all those places. And the entire purpose of these streams and the tech news that I do, the tech bites like I'm going to do tomorrow, going over how AI sucks and you should stop using it. Please stop using AI. It's terrible for you. It's terrible for society. And it's a complete hand-wavy magical BS system anyways. It doesn't do what you think it does. I've spent the last year and a half going over all of the science and the programming and all of that and how exactly it sucks and why it's not what you think it is. I talk about technocracy. I talk about all kinds of stuff, man. So if you like all this stuff, you like the video game streams, you want me to keep doing this kind of stuff, you want more of it, then please make sure that you do the like and the subscribe. And I appreciate all the follows on Twitch. That's very helpful. It helps the algorithm and all that good stuff. If you can't part with a few dollars, I can appreciate that, because it's difficult to do that. It's a I've been there. Sometimes just even finding $5 to part with can be tough, and it's not exactly easy to do that, right? But it's free. Like, subscribe, all that good stuff. Those are all free. So just make sure that you're doing that, please. That's the only thing I will ask. Okay, I'm gonna find. Shut up, Erikar. You suck. You suck. I'm gonna find some people to. I'll raid over to. Oh, I know who I'm gonna raid over to. Okay, so I'm gonna set up. I'm gonna move you guys over. There's gonna be some good stuff. I'll see you guys tomorrow. I'll be back tomorrow. Thanks everybody for watching. I appreciate it. And that's it. I'm gonna end the stream. Peace out, everybody. Have a good one. Enjoy the rest of your Sunday/Monday, however it may be.